video is on Unit 6, Chapter 13 on natural logarithms. Lesson number 1, solving natural log equations. What is E? E is an irrational number with an approximate value of 2.71828 ... The dots, of course, are going to represent the fact that this number does not end. E often occurs as the base of an exponential and logarithmic function that describes real-world scenarios. So on your calculator, you can find pi. You can also find E, which is blue, and it's on the divide button. So second divide brings up your E. If you hit enter, it has what it has stored in the calculator for E, the 2.718281828, and then it's going to continue on. There's also another one, which is second ln next to the 4, which is E, and it opens up an exponent box for us there. We might need that later as well. So I'm going back to our notes. Base E, exponential functions. Exponential functions with base E are called natural base exponential functions. The example that I have here is f of x is equal to e to the x, where e is your base on the exponent. Base E logarithmic functions with base E are called natural logarithms. And an example here is f of x is equal to log base E of x. And this is often abbreviated as f of x is equal to the natural log of x. So rather than writing log base E, we just write it ln. And that is an L, it is not an I. So converting between forms, our directions here are going to tell you to write each equation in logarithmic form for numbers 1 through 3. So for number 1, it says e to the x is equal to 24. So that would be log base E of 24 equals x, except we don't write log base E. So this is just natural log of 24 equals x. So all of the rules that we learned in chapter 12 are also going to apply here in chapter 13 in lesson number 1. Lesson number 1 is going to kind of include everything that we learned in chapter 12, how to convert from log form to exponent form to log form, condensing, expanding, solving, all of that is included in just this one lesson. Let's do one more. Number 3, e to the x plus 5 is equal to 72. Again, normally you would write that as a log base E of 72 is equal to x plus 5. But because we don't write that, we use a natural log. It's going to look like this. Natural log of 72 is equal to x plus 5. And then for the next set, we're going to go from logarithmic to exponential. So write each equation in exponential form. Number 4 says the natural log of x is equal to 58. So that's going to be a base of e to the 58th power is equal to x. Same thing on number 6. E to the 32nd power is equal to the x minus 9. So that's converting, just like we did back in chapter 12. Now, moving on down to simplifying, it says condense each expression into a single log. So on number 7, we've got our product property, natural log of 3 plus the natural log of 16. The plus tells me to multiply. So you're just going to do your 3 times your 16, which should be 48. On number 8, there's a minus between, which is going to indicate division, but you also have the product, so that's your quotient property. You also have the power rule. So this 2 times the natural log of 3 means the natural log of 3 squared, which is 9. So this is natural log of 63 minus natural log of 9. And now we're going to divide 63 by 9 and get natural log of 7. And then number 9 is the same. I'm going to move my 1/3. It's a product. Now it's a power. Same thing for the 2. The plus in the middle means I need to multiply. So let's reduce this. Natural log 64 to the 1/3 power is the cube root of 64, which is 4. And then we're going to multiply, and we get our 4x squared. And I'm going to put parentheses around that because it's more than one thing going on. For expand, we touched lightly on expand in the last chapter. And same thing here. If you look at number 10, that's the natural log of 5 times x. So we'll use addition to separate them. Number 11, I'm going to change this. I'm going to reduce the power on the outside. So all I've done there is I've distributed that 2 that's on the outside of the parentheses. And now I can rewrite this. It'll be the natural log of a to the 6 minus the natural log of b squared. And then the last step is to move your exponents to a product. And there's that expand. So it's just knowing your rules frontwards and backwards. So the next section is all about solving our equations and the strategies that we learned in chapter 12 are going to apply here as well. So solve each equation below, check for extraneous solutions. Number 13 has a log on both sides. So ln is still a log. It's a log with a base of e. And since we have logs on both sides, we're going to use that strategy where we drop those logs and solve the equation that's left. I'm going to add the 2x. So I'm going to move this. So 4x plus 2x is 6x. Then I'm going to add the 27. So 15 plus 27 is going to be 42, and then divide by 6, and I get x equals 7. And just like in chapter 12, when it is a logarithmic equation, you must check your solutions to make sure that none of them are extraneous. To save time, I am going to tell you that x equals 7 will work. But again, you're checking that in the calculator. I'll show you on this one, on number 13 only. So we're going to go to the calculator. The left side says the natural log of 4x, so we got 7 for x, minus 27. And there's the left side. Now, hopefully the right side says the same thing. 15 minus 2 times 7 also gives me 0. So as long as there's no I involved, we're good. So that's how you check. All right, let's keep going. Let's look at number 14. Number 14 says 2 times the natural log of k is equal to the natural log of 2k plus 15. So before I can drop my logs here, I do need to make sure I condense both sides into just one log. So that 2 needs to be moved to the exponent. And now I've got natural log of k squared is equal to natural log of 2k plus 15. And now we can drop those logs and solve the equation that we've got left. Now it is a quadratic because we have a k squared. So I'm going to subtract the 2k and subtract the 15. And then I'm going to solve by factoring. So I need two numbers that multiply to give me negative 15, that add to give me negative 2, which would be a k minus 5 and a k plus 3. So when I solve this, I get k equals 5 and k equals negative 3. Now, are they both going to work? So going back to the original, we learned in chapter 12 that we cannot take the log of a negative number. So if I plug in a negative 3 for that k right here, the negative 3 is not going to work. But the 5 should work on this one. So k equals 5. Again, you would want to take a little more time and check that. Let's jump down to number 18. On number 18, what you should notice here is that you have logs on one side, not both. So this is one of those instances where we have to change from log to exponential. But before we can do that, we need to condense the left side into one log. There's a minus in the middle, so we're going to use division to do that, to change it, to condense it. Sorry, wrong word. To condense it into one log. So from here, what I'm going to do is I'm going to change it to exponential. On that natural log, the base is e, so now it says e to the 7th power is equal to x divided by 9. So e to the 7th power, we're going to use that button, second natural log, e to the 7th is 1096.633 is equal to x divided by 9. So then we'll multiply by 9 and find that x is equal to 9,869.698. Again, you would want to make sure that you double check, plug that in for x, and make sure that the left side does equal the right side in the graphing calculator. I will let you know that it does work. Let's jump down to number 19. So notice on 19, 20, 21, and 22 that these do not say log. So these are our exponential functions. And think back to your rules for exponential equations and how we would solve those. The nice thing is that with the natural log, you only have one choice. We cannot get the same bases on both sides because the base is an e, and that's just not possible. So the only thing that we can do here is change or get the exponential part by itself and then convert it to a log and solve. So on number 19, the exponential part is already by itself. I'm going to write this as a natural log. So it's the natural log of 57 is equal to x. Now, if you need to go through that step where you're saying log of e of 57 is equal to x and then convert it to a natural log, I'm okay with that. But please never write your natural logs in that form. So all we have to do is take the natural log of 57, which is a button. So your natural log is right next to the 4. Plug in 57, and our answer is 4.043. And there's your answer for number 19. And then let's look at number 22. So I said a second ago that in order to do these, you do have to make sure that your exponential part is by itself. So that 2 must go and the 3 must go, and we have to get rid of the 3 first. So it's a plus 3. We're going to minus the 3. 87 minus 3 is going to be 84. And then we'll divide both sides by the 2. And you get 42. And then we're going to change it back to a log, which is your natural log of 42 is equal to c minus 9. So then we'll take the natural log of 42 and get 3.738 is equal to c minus 9. Add your 9, and we get 12.738. And there's your answer for number 22. So as you can see in this lesson, it takes us through all of the concepts, standards, and rules that we learned in chapter 12, changing from logarithmic to exponential. The only difference here is that these logs are natural logs, so base of e. And then your same rules for solving logarithmic equations also apply in this chapter 13, lesson number 1 for natural logs.